FastMCP 2 implements a protocol-native task execution system that enables asynchronous operation handling through a decorator-based configuration pattern, allowing developers to specify 3 distinct execution modes that govern how client requests are processed. This mechanism leverages the TaskConfig class to define behavioral constraints at the function level, creating a flexible interface between synchronous and background task processing. The upcoming code artifact will demonstrate how these execution modes are declared and configured within a FastMCP server instance, showing the initialization of task-enabled components and their respective behavioral specifications through decorator parameters. From FastMCP, import FastMCP. From FastMCP server tasks, import TaskConfig. MCP equals FastMCP my server. Hash supports both sync and background execution default when task equals true. At MCP, tool task equals task config mode equals optional. Async def flexible task, SDR. Return works either way. Hash requires background execution errors if client doesn't request task. At MCP, tool task equals task config mode equals required. Async def must be background SDR. Return only runs as a background task. Hash no task support default when task equals false or omitted. At MCP, tool task equals task config mode equals forbidden. Async def sync only SDR. Return never runs as background task. This code demonstrates FastMCP's task execution mode configuration using TaskConfig, which provides fine-grained control over how tools handle synchronous versus background execution. The 3 modes, forbidden, optional, and required, dictate behavior when clients request task execution, enabling developers to enforce or restrict background processing as needed. The flexible task function uses mode equals optional, allowing it to run either synchronously or as a background task, depending on the client's request. This is the default behavior when task equals true is set, offering maximum flexibility. In contrast, must be background enforces background execution with mode equals required, ensuring long-running operations don't block the client. Meanwhile, synchronly explicitly disables background execution with mode equals forbidden, forcing synchronous execution even if the client requests a task. These modes align with the MCP protocol's graceful degradation principles. When a client requests a background task for a forbidden mode component, FastMCP falls back to synchronous execution, maintaining compatibility. Conversely, required mode components reject synchronous calls, enforcing proper task usage. This design balances flexibility with control, allowing servers to optimize for both performance and client experience. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol MCP servers. From FastMCP server tasks, import TaskConfig. Imports the TaskConfig class from the FastMCP server tasks module, providing access to task configuration functionality within the FastMCP framework. MCP equals FastMCP my server. Creates an instance of FastMCP with the server identifier, myServer. The string parameter serves as a label for the server that will be visible in MCP protocol handshakes, allowing clients to identify this specific server instance during communication. At MCP, tool task equals task config mode equals optional. Decorates the following function as a FastMCP tool with optional background task execution mode. When invoked without a task parameter, the function runs synchronously. When invoked with a task parameter, it executes asynchronously in the background. Async-def flexible task, SDR, defines an asynchronous function named flexible task that returns a string value. The function signature indicates it can be awaited and will produce a string result when called, but the implementation details aren't visible in this segment. Return works either way. Returns the string literal, works either way, as the output of the function. At MCP, tool task equals task config mode equals required. Async def must be background SDR. Defines an asynchronous function named must be background that returns a string, decorated with @MCP tool configured to require background task execution. The task config mode equals required parameter enforces that this function must be called as a background task, rejecting synchronous execution attempts with an error. Return only runs as a background task. Returns a string literal indicating the function or method is designed to execute exclusively as a background task, preventing synchronous invocation. At MCP, tool task equals task config mode equals forbidden. Decorates the following function as a FastMCP tool with task execution mode set to forbidden, meaning the tool will execute synchronously and will return an error if a client explicitly requests background task execution. Async def synchronly SDR defines an asynchronous function named synchronly that takes no parameters and returns a string value. The function is declared with async def, indicating it can use await expressions internally, but the actual implementation isn't visible in this segment. The return type annotation, SDR, specifies that callers can expect a string result when this coroutine completes. Return never runs as background task. Returns a string literal indicating that the operation will not execute as a background task. This is a direct response that communicates the task execution mode to the caller. FastMCP2's decorator-based task configuration provides a clean way to control execution modes at the function level, using TaskConfig to enforce 3 distinct behaviors. The optional mode offers maximum flexibility, allowing functions like flexible task to run either synchronously or as background tasks based on client requests. In contrast, required mode strictly enforces background execution for operations like must be background, preventing synchronous calls that could block clients. Meanwhile, forbidden mode ensures functions such as sync only always execute synchronously, even if a client requests a task, maintaining predictable behavior for time-sensitive operations. These modes work together to balance flexibility and control, aligning with MCP's graceful degradation principles. When a client requests a background task for a forbidden function, FastMCP falls back to synchronous execution, ensuring compatibility. Conversely, required mode functions reject synchronous calls, enforcing proper task usage. This design allows developers to optimize both performance and client experience by explicitly defining execution constraints at the tool level, all while maintaining protocol compliance.
The forbidden task runs while the required task waits. Yet the optional task dances between both worlds,